Ladies and gentlemen, I'm honored today to introduce you this special session on the energy and the city of the future, which will be a brainstorming of idea about this symposium for the session of 2020. The energy and the city or wheel of the future is a series of international events dealing with the city and the science. The city is a laboratory of meeting between dreams and realities. At a different scale, citizens have to manage daily and to make a better tomorrow. The history of the International Conference on the Energy and the City of the Future started in a simple coffee break in Sergi Pontoise, close to Paris, between Professor Mohamed Dar Sharif from PMI, Professor Nancy from Queen's University in Canada, Professor Ben Nasser from Ines Kashan, and myself, Professor El Ganawi from University of Lorraine. This simple discussion was so rich that we decided quickly about three institutions immediately to create a series of events with a specific spirit to couple under common exchange to mix together scientists, visionists of tomorrow, industrial, and policies of the city. Professor Ben Nasser and Jean-Michel Bricaire helped us continuously and joined the adventure in official sense about the email association in this session of 2020. Thank you for them. Then the symposium became the place to be for dreaming about 2050 city, then starting in Sergi, followed by Queens, followed by north of Morocco in Martil, the scientific basement of the conference being built in French language. Without imagination, future can't find any support to materialize human progress. As sketched on the slide that you see, the city of Longwy, which is a very small city in the north of France, in frontier between Belgium, Luxembourg, Germany, there is an imagination of 2050 and worked 2 days of the EVF symposium on 2017. Without a memory, future doesn't make any sense. This is a picture of our EVF in Fez in Morocco, a city old of 1,200 years. The conference served here as a bridge to connect past and future, history and future. Then we go to the city of Pune in India, close to Mumbai. This city with more than 3.5 million inhabitants become a city who gives some maturity to our event because the event traveled from the Francophone area to Anglophone area to a big country with a huge question on energy, materials, and cities. Here the edition reached the international dimension with full English presentation and paper published in E3Z proceedings. The next edition was supposed to held in Paris, but as you know, because of the health crisis, our session of today is supposed to make a brainstorming, serving potentially to alimentate the topics for coming events. All editions needed a huge organization. Warm thanks to Professor Desano for dressing the summary of Longwy edition, Professor Zorkani for Faz edition, and special warm to Professor Sridharshan for dressing the summary of Pune edition and for his group for such a huge work for organization, the Symposium of Pune. Our edition conclude with a signed document from scientists, citizens, political leaders on a strong intention on working on a common future of a better city, sustainable, making science and progress in the service of a better life of each and of all. This format making possible the session starting from in Canada at 8 a.m. and ending in India 10 and a half hour later. That allow us a panoramic vision on EVF history and progress for a city taking advantage on renewable resources for housing and mobility, energy, etc. Taking to women in the center of the scientific and the technical progress. Many thanks for Queen University and University Mohammed VI in Morocco for hosting the online edition. Warm thanks to our speaker from Canada, Cameroon, France, India, Russia, and we wish you a big success and a long life to this event serving Homen and the city. Thank you. Welcome.
Yeah, I am always interested by global warming and to try to stop this global warming with two means. One main mean is to use wood for with two possibilities: using wood as a building material and using wood as renewable energy. So to remind the problems, it's always important to remind the problems. You have this curve, which is a curve. I don't know if you see all the curve. You see it has been modelized until 2020, and you see the curve fits perfectly with the average temperature, measurement of average temperature. And we know that we have a very big problem. For example, this month of November, I don't know in Canada, but in Europe, it was the hottest November we have ever had in Europe. It's a problem. And when you are trying to understand, oh, sorry, it's too sensitive. Oh, no, sorry, I come back. When you are looking at the reason why we have this increasing of temperature, it's mainly due to the increasing concentration of greenhouse gases, mainly CO2 and CH4, produced by human and cattle. We must not forget cattle activities. Also with, for sure, burning of fossil fuel, agriculture, deforestation, and deforestation is very important, mainly this year with enormous forest fire we have had in Australia, in California, and in Siberia, enormous forest fire. Yeah. And there is another problem, a very big problem with permafrost thawing. It will represent about 50% of fossil fuels CO2 increasing with combustion. And when we are looking at the direct measurement or CO2 direct measurement and CO2 I scores, we see that we have an fast increasing, and the last year very, very, very fast increasing, and it's a very big problem. I was talking about permafrost thawing in Siberia. When you are looking at this landscape, normally the landscape is very flat, like here. Yeah, we have only some lakes. But in northern Siberia, this year in summer, we have had this kind of flakes, yeah, kind of flakes appearing. It's warming, defrosting, and with evolution of CO2 and methane. And it's a very big problem. They have had a problem in Norilsk, which is a city producing with big industry in nickel, and the facilities are going down because of this permafrost thawing. When we are looking at CO2 per capita, we observe that some efforts have been done. For example, in USA, but the results are only until 2009. We don't know what will be the result after the policy of President Trump. We observe this interesting curve in clear blue. It represents CO2 per capita for, in fact, for Russia and Eastern Europe countries. You have a peak until 1990, and after you have the collapse of USSR, and a lot of plants were destroyed, not only in Russia but also in Eastern Germany. We have an increasing of per capita of CO2 in Asia, Oceania, mainly Australia and New Zealand, and always an increasing for China. But for China, as it is per capita, it seems that it's not a lot. But people in China, we have a lot of Chinese, so it represents a large quantity of CO2. This quantity of CO2, you have it in the next map. This map is interesting. It's coming from this link. I recommend for you to go to this link because you have a lot of interactive maps giving a lot of information. And we see that the first rank for CO2 is China. They are trying to make efforts with reforestation, for example. They are the first in the world for reforestation, but it's not enough. After you have US, mainly US, and India, because you have a lot of people. In Europe, it's mainly Germany. But Germany, because they have stopped their nuclear plants, they are replacing their nuclear plants by coal power plant, and it's really a very big problem. Quite the same in UK. In UK, they have also a lot of coal power plant, but actually they are replacing with this coal power plant. They are replacing them with pellets, wood pellets power plants. Sorry, again. Yeah. And Russia. Russia, they are not making a lot of efforts. Fortunately, their industry actually is not very well developed, but nevertheless, they need to make a great effort. It's necessary to reduce these greenhouse gases, and the main strategy to reduce these GH gases is to trap carbon, is to have a carbon sequestration. And we have different ways of carbon sequestration. We can have CO2 sequestration in forest, but only in second growth forest, not in primary forest. We can store carbon in wood products and mainly in buildings, and we can replace also carbon intensive materials by these non-renewable raw materials by materials coming from with materials which do not consume too many carbon. in manufacturing. Not just to talk about natural forest, old growth of primary forest. It's very nice to have these forests, but it's only good for biodiversity. You have a natural carbon balance, and in fact, it's useless to fight against global warming unless logging and replant new forest, because you have an equilibrium between carbon sequestration by photosynthesis and carbon release by respiration and decomposition. The best, another remark, sorry, another remark, when you are talking about forest, we are talking about the vegetation. We are, oh, sorry. Sorry. We are forgetting the carbon stocked in the soil. And when you are looking at agriculture, for example, agricultural land, you have only, oh, in agricultural land, you have only, you have only soil. Vegetation is it's very small, in fact. In boreal forest, you have vegetation which trees are not very high in Arctic forests like in Canada or in the north of Russia, but we have a lot of carbon in the soil. It's an explanation about the very bad influence of global warming for permafrost. Yeah, in temperate forest in Europe, for example, we have an equilibrium. It's not a lot. Tropical forests are interesting for vegetation. You have large vegetation and also a lot of carbon in the soil. Secondary forest, that's a forest which are interested to manage the carbon sequestration. You have a carbon stock and then carbon sink. Carbon stock is the carbon which is inside the forest. Carbon sink is the carbon which is stored. It's a dynamic process. We have formation of trees or even agriculture. Yeah? And we in this forest to have good action, you need to harvest mature trees, and in that case you avoid the end of life decomposition and CO2 release. It's a source of wood, and that's our material, which is important, and also forest products, but it's mainly for wood for construction. These forests are planted forests or naturally regenerated. We can have clear cut of these forests, but after clear cut, we need immediately to replant. And to have a good evolution, the harvested volume must be a bit less than biological production. And what we know is that in temperate forest, when they are managed and harvested, we trapped about 3 tons of carbons per hectare and per year. Yeah, for a boreal forest, it's a bit less. It's about 2. The best is in tropical forests. When they are managed and harvested, it's about 5 tons of carbon per hectare and per year, but except in desert. In secondary forest, it's possible to increase this process by extension of the resource, plant more trees. To somebody, I am in the Academy of Agriculture of France. I am a fellow, and one time we have had a discussion with colleagues, and one was proposing to make Sahara green again, But the main problem with Sahara is the lack of water. So he was thinking that probably it was possible to build a lot of nuclear power plants on the coast of Sahara to have desalinization of water. Or eventually it could be perhaps possible to use more I would say solar cells, solar heaters. There was somebody in Morocco who was planning to do that. And in this forest, we need to limit harvesting to the biological production. I repeat, that's very important. But big problem actually for this forest is the loss. We have a very big loss with forest fire. I have already told something about that, and insect. For example, even in France, in the northeast of France, we have a very big problem with spruce. We have some beetle, and the worst was in British Columbia. About 15 to 17 million hectares in British Columbia are dying, and they are converted in wood pellets. And probably we need to have a new silvicultural approach. In forest products, it's mainly for building with wood, different wood products, sawn wood, engineered wood products. That's the main part, and it's developing very fast. Boards, furniture, paper, until end of life, and we will try to keep them the longest time possible. Yeah, we need, but to have this process well maintained, we need to increase the durability of wood with wood protection. When you are, I'm talking about building, the situation for building is really relatively dramatic. When you are looking at the effect of buildings actually on the environment, it's a problem for wide years, yeah. 60% of global resources are consumed by buildings. 50% of production of waste are with buildings, and 35% of global energy consumption with buildings. 35% of CO2 emission related to global energy consumption are coming from building. These figures are very new. They were given the beginning of December in a Congress in Germany. So we need to do something. The legislation, I told you that we have a lot of waste production with buildings. And actually there is a legislation to have a new law about waste hierarchy according to circular economy law. It's coming step by step, but at first we need to reduce the waste, then reuse the waste, if not possible recycle the waste, and at least energetic recovery when it's possible, and finally landfill. But actually different countries are trying to reduce sharply the landfills. What are the benefits of building with wood? We have large development since about 10 years and more of engineered wood products. We call it massive wood. We have CLT. CLT is cross-laminated timber. It's a new development which is coming from Austria, from Graz University. And the professor who has who has developed this CLT, has had this year the Wallenberg Prize. In Wallenberg Prize, we call it, it's a Nobel Prize for forest and wood sector, yeah, which is given by the King of Sweden. You have glue lamps since a longer time, and laminated vinyl timber. These wood products, the manufacturing of these products are using much less energy than the other building materials, and so in that case you have less greenhouse gases. You have for wood products lower carbon footprint. The manufacture of concrete and steel accounts, when you are looking at on the world about when we are looking at the global production of greenhouse gases, we say 8% are coming from concrete and steel, and it's quite a lot. And up to 10% of annual global carbon emissions are stored in wood buildings. When we have wood buildings, we can store a maximum, it's a maximum, 10% of CO2. It's the case, for example, in Sweden, and probably it could be the case in Canada also, yeah. This carbon remains locked inside wood products for a long time. It's a carbon stock, yeah, and important to have this carbon stock. Yeah, the benefits of building with wood. It's a great competition with people from concrete, yeah, and steel. Timber-based buildings take less time to build with prefabricated mass timber panels and beams. It's possible eventually one man can build his house himself. Smaller crews assemble structure more safely and quickly, saving time and money. But the greatest amounts of wood are used in not in high-rise building. High-rise building is very good for publicity for wood building, but in fact we don't have a lot because there are some drawbacks we'll see later. Greatest amount are in mid-rise building, 4 to 10 stories. I remember when I was living in Quebec, I was living in a four-store building. It was in the 70s, let's say 70s, and this building was made completely with wood. I came back to visit the place last year, I guess, if I remember. This building was always existing, perfectly clean, and with a lot of people being inside. So the durability is very important. So it's mainly in residential apartment, commercial buildings, hotel, and also what is important, I've made a picture here. You have a house in Bordeaux, which has had an additional story with additional story, and it's a fashion actually to increase the number of flats and apartments in cities by additional story. And quite all of these additional stories are made with wood because it's lighter. It's lighter to put such a wood construction on existing flat or existing building. We have remarked that children are less stressed in classroom made with wood. And somebody say also that office workers are happier and more productive in buildings in wooden buildings, probably better than with teleworking, I guess. Yeah. Most important is the link with forestry. EWP products use smaller pieces of wood, not large trees. It's better for CO2 sequestration. because these products, they will come from reforestation with smaller trees. And these smaller trees grow faster in a few decades, much faster than large trees. Large trees is very beautiful, yeah, to have a promenade in a forest with large trees, but in fact we need smaller trees. And actually, when you are looking at the price of food, the market is for medium-sized trees, not with large trees. Sometimes we don't know what to do with large trees. But with wood construction, we have some drawback. The main drawback is the combustibility. Here you have the famous building fire in London 4 or 5 years ago. Yeah, that's a problem for multi-story buildings in comparison to steel. But in comparison to steel, glass, or concrete, we must know that normally with wood you have combustibility. The combustibility of wood produce char, and char is an insulating product. It means that when you have a large cross-section piece of wood, the durability during a fire is longer than the durability of steel. With temperature, the steel is losing its mechanical properties. For wood, you have time to go out normally. So for this kind of high-rise building, we need to improve the fire resistance. There are different means to improve fire resistance. It's possible with chemical treatments with fire retardants, for example, or eventually with cladding. When you are looking at individual houses in North America, they are all made with wood, but the cladding outside is made with stone, for example, or eventually plastics, yeah? or steel or glass. Yeah. Another problem with wood is high moisture. High moisture, if you have high moisture, you have a biological degradation, and humidity change induce dimensional variation. So you need to have moisture protection, which is necessary. Another drawback is environmental and local tradition, history, timber resource. For example, I cannot imagine in South Morocco to have a lot of wooden house, except in Ifran, in the north, you can have a wooden house, because in other cities it's not a tradition to have a wooden house. It's the same in Provence. This picture is a picture of Provence village. We cannot imagine to have a wooden house inside, except if we want to have additional stories. Yeah. Oh, I am always a bit too long, so Mohammed, you need to stop me if I am too long. Yeah. When we are looking at the lifetime of wood products, the longest lifetime is in wood construction and frame. After joinery, even wood for energy, you have a short lifetime, but 1 month to 2 years. But it represents a large quantity of carbon stock. That's an example, a classical example of the carbon stock in a house, in a complete wooden house. Yeah, we have different quantities of CO2 which are stocked inside. Main part is in frame and main part is in frame and walls. To compare, for example, when you are looking at the manufacturing of polyvinyl chloride window, The equivalent is 63 kilogram of CO2 equivalent. For a wood window, all included, even glass, yeah, you decrease to 40 kilograms of CO2. So you have an advantage to replace plastic window by wood windows. Another advantage is that, for example, in when you have high temperature, the plastic is becoming soft. When you have low temperature, the plastic is broken very often because of the low temperature. So wood is the best material to build windows. The only problem is the cost or the price. Yeah. What is important with the life cycle of material is this cascading usage of timber. You remember reuse, recycle, etc. Here we have the detail for this cascading usage of timber. Since 5 years, people are trying to develop this cascading, even until the last use, which is energetic recovery. When we don't know what to do with the last waste, you have energetic. But between fiber-based products and energetic recovery, you have another product which is largely used in, if I remember, in UK. We call it, I don't remember the name, mulch, yeah? Mulch, which is used to prevent the foot of trees, for example. You use mulch with different colors, yeah. After building, it's possible to replace a lot of raw materials and chemicals by wood-based materials. As I told just before, to replace concrete, PVC, aluminum. Large industry doesn't like this competition with wood. And actually some companies in France like Vinci or Eiffage, they say that they are producing low carbon concrete, but it's not so low. Yeah, you have something which is very classical. I have already shown this figure many times. You have the difference in embodied energy between wood and aluminum, for example. Yeah, but aluminum is very stable, and very often we are using mixed products, for example, for windows. Myself, I have used mixed window with aluminum outside and wood inside recently. For energy, we need to assume carbon neutrality, but sorry, I'm not a good manager of PowerPoint. Actually, if we assume carbon neutrality, and we need to be very careful with carbon neutrality. We must understand that when you burn, you cut a large tree, for example, you cut it into pieces, and with these pieces of wood, you put them in a furnace in a central heating plant. 1 ton burns in 15 minutes, and how much time it needs to grow this large tree? Perhaps 1 century. So carbon neutrality is very difficult, yeah, to assume. But nevertheless, actually in Europe, would represent 50% of the renewable energy in Europe. and it comes from clean wood, from stems, 50%, and 50% residues from harvest operation, end of life products, and industry residues, or eventually yeah.
Ouais. Oui, cher Xavier,
When you compare the renewable energy, the figures have not changed a lot. Yeah, main quantity of renewable energy is coming from wood and biomass, then hydroelectricity, wind, geothermal, biofuels, photovoltaic, and tidal, yeah, in the sea. It's very small, yeah. It's mainly wood and biomass. How you can compare, but I will not detail because I am a bit too long. You can compare, sorry, you can compare the different wood and fossil fuels, the average values. You see, when you compare coal with dry and split logs, coal is 2 times wood. Oil is more important, yeah, but it's the same range, more or less the same range. And what is fashion actually for? I was talking about UK, not only UK but Netherlands, for example. They are replacing their coal-fired power plant by toasted pellets power plants, and these pellets are coming from Canada and eastern coast of US. And toasted pellets, when you are looking at the figures, you see that average value is 6.1 to compare with wood, with 8 for wood. And there is an enormous market about on these wood pellets. And it's starting in our country, in France, but in Europe, we are the greatest consumers for pellets coming from North America. Another, I am quite at the end. Yeah, I am talking about biofuel processes. We have a lot of biofuel processes. Lot of biofuel processes. Some of them are theoretical, the free furs, for example. And a value which is very important is this value which is very often not taken into account by people, by green people. It's ROI. ROI is the ratio between energy recovered over the content of energy of your resource. Yeah, and one thing which is important, you see, biogas to liquid fuel, no interest. Yeah, ROI is 0.7. And what is interesting is this one. It's a biocrude coming from not only biomass but urban waste and a lot of carbon waste, or waste containing carbon. It's rather simple process and a scattered process at the same time. I want to show you this. Yeah, it's this process. It's old and new. We have start with this process in '85 at the lab, and we have started on wood liquefaction for Elf company. Yeah, they were interested in the '80s. Yeah, and now it's it was a sleeping process until the beginning of our century, and it has been developed since that time in a direct hydrothermal liquefaction, a new and old process. And the advantage is as biomass sources are scattered, you have small plants. You can have a lot of small plants producing a crude oil, 15 minutes. It's I would say it's not a continuous process, it's a batch process. 15 minutes, 350 degrees Celsius, and 220 degrees. Yeah. Efficient, quite good efficiency, and not very expensive. So this parameter is very important. We must always think about this parameter. When we were looking at oil coming coming from Texas in the 1930, or even from Saudi Arabia, you have only to drill the ground and you recover oil. So ROI is very high, 100 the maximum. Coal is not. Oh, I'm sorry. Yeah. Coal is not too bad, and wood is about 30. Wood is about 30, and when we detail, a lot of people. Oh, I'm really sorry. Yeah. So I am lost. Perhaps it's time to stop. Where is my?
Excuse me. Maybe Mr. Deglise, can you hear me?
Okay.
Dr. Deglise, can you hear me? We are. That's a very interesting conference, and I have registered.
Biodiesel. Biodiesel is people are talking about biodiesel coming from wood gasification and Fischer-Tropsch. It's very complicated, and you need large plants, large facilities. But when we compare with ethanol, you see, ethanol is not very interesting. Ethanol, because you produce 1.3 kilojoule and you use 1 kilojoule. Yeah. Ethanol sugar cane from Brazil, for example, is much better. Yeah. So better use sugar cane to produce ethanol than corn, and wood also. With wood is not very interesting because we don't have enough cellulose inside ethanol. Hydroelectricity for sure is the best. Yeah, because you are not using. You are only using Earth's attractivity, yeah, by falling down of water. Fuel wood is not too bad, but you produce CO2 with fuel wood. It's not too bad. About 40 with combined heat and power for power plant. Without heat and power, it's 30. Oil and gas, 70s, about 30. Oil and gas coming, for example, from the new coming from US, yeah. In fact, it's not very interesting because it costs a lot of energy, yeah. And that was this oil and gas extraction, which was promoted by Trump. Not very good concerning energy. We are losing a lot of energy. Photovoltaic, it will change, I guess, yeah, because we have progress in the solar cell. Shale oil, that in fact, I was talking about shale oil. You see, it's 5, so not very interesting. And hydrothermal liquefaction between 7 and 15, not too bad, yeah. Why I am talking about this hydrothermal liquefaction, and I am finished now. It's because we are thinking about electricity for cars, even trucks. But problem is with planes. For planes and truck, we will need, I guess, in my opinion, always some liquid fuel. And we have enough biomass to produce liquid fuel for planes, for example. For example, in France, with 5 million cubic meter of wood, we can produce all the fuel which is necessary for planes. But in fact, we have a lot of urban waste, and we don't know what to do with this urban waste. And probably mixing urban waste with biomass, and so we can produce a fuel like heavy fuel number 2, for example, and we can refine this fuel in existing refineries. So, in my opinion, it's a good way to keep fuel for heavy transportation, boats, planes, etc., and trucks.